Just like arithmetic sequences, geometric sequences also have a sum, or which is called geometric series. And the formula for the sum of geometric sequences is S of n equals the first term times a fraction. In the numerator you have 1 subtract the common ratio to the nth power divided by 1 subtract the common ratio. R does not equal to 1, and n is the number of terms you would like to add up. So here on this slide we are going to find the sum of the geometric sequence starting from the first term to the 10th term, and the formula for the sequence, or the rule for the sequence, is 4 times 3 to the k minus 1. So let's get started by writing the sum formula for a geometric sequence, which is S of n equals a sub 1 times 1 minus r to the nth power divided by 1 minus r. So let's list all the pieces of information that we need. So a sub 1, or the first term in our case, is going to have a value of 4. The common ratio has a value of 3, and n is going to be 10 because we want to add up the first 10 terms. So let's substitute the values into the sum formula. So the sum of the first 10 terms is going to be 4 times 1 minus 3 to the 10th power divided by 1 minus 3. So now we are going to continue evaluating the formula. So the sum of the first 10 terms is 4 times 1 subtract 59,049 divided by 1 subtract 3. So the sum of the first 10 terms is 4 times negative 59,048 divided by negative 2. So the sum of the first 10 terms is going to be 4 times 29,524. So finally the sum of the first 10 terms is going to be 118,096. So in this real life problem, we are going to calculate a monthly payment for a loan with the given formula, where L is the loan amount in dollars, I is the monthly interest rate in decimal form, T is the term in months, and then we need to calculate the monthly payment on a 5-year loan for $20,000 with an annual interest rate of 6%. So let's get started to figure out some of these pieces of information that we need for the formula. So we know that in the formula, L, which is the loan amount, is going to equal to $20,000. We also know that the interest rate is 6%. So 6%, however, we need the monthly interest rate. So if it's a 6%, we are going to convert that into a decimal form, which is 0.06. And to find the monthly rate, we are going to have to divide this 0.06 by 12, which will give us 0.005. So this is going to be the value of I, 0.005 in our formula. And then since we want a 5-year loan, so the loan amount of T is going to be 5 years. However, we'll need to have this in months. So T will equal to, in months, is 5 times 12, which is 60 months. So let's substitute these values into the formula. So the monthly payment is going to be $20,000 divided by the sum of k equals 1 to 60, 1 divided by 1 plus 0.005 to the k exponent. We know now that the sum formula for a geometric sequence, which in the denominator will have a geometric sequence, is going to be the first term times 1 minus the common ratio to the nth power divided by 1 minus r. So now we are going to first substitute in the 1 into the formula to figure out the first term. And if I substitute 1 into the formula, the first term is going to equal to 1 divided by 1.005. And this value is also going to be our common ratio, and I'm going to represent it by capital R. So we're going to use our graphing calculator to punch this into the graphing calculator and to store this value, so when we are substituting into a formula, we're going to be able to use the calculator. So to store this number in your graphing calculator, punch in 1 divided by 1.005. Then I would like you to press the button which says STO and a right arrow on it. So it says STO and an arrow. So that means store the number. And then you're going to press the button that's called alpha. It's a green button on your calculator. And then last you're going to press the button which is the multiplication symbol. So now you just stored the number value of 1 divided by 1.005 under the variable r. When you punch these buttons into your calculator, you should be given a value for r which is approximately 0.9950248756. So because this decimal has a lot of digits in it, that's why we wanted to store it in the calculator for r. So now we are going to substitute into the sum formula. So we'll say the sum of the first 60 terms is going to be r times 1 minus r to the 60th divided by 1 minus r. When you punch this in the calculator, don't forget you need to put an extra set of parentheses to find this value. So let's go ahead and punch this in our calculator. So to punch this in your calculator, you're going to say alpha and press the multiplication symbol, which calls r, and then open up 2 sets of parentheses, and after the second parenthesis you're going to put 1 minus r to the 60th and close your parentheses once, and then divided by parentheses open 1 minus r, parenthesis closed again, and close it twice. And r is always going to be alpha and the multiplication symbol. So once you substituted this in your calculator, you're going to have the sum of the first 60 terms is going to be approximately 51.72556075. So now if we substitute this number into the formula, so the monthly payment is going to be 20,000 divided by 51.72556075. And to do this, you punch in the calculator 20,000 divided by, and then you press the second button and the minus symbol, which will pull up the answer of the 51.72556075. And so your monthly payment rounded to the nearest hundredths place is going to be $386.66. After this slide, you will have 4 monitoring progress problems to do. So please go ahead and do those before you look at the next slide.